In this last slide deck, I'm going to talk about troubleshooting in Linux. Arguably the most important tool we have for troubleshooting in Linux is log files. Anytime you're troubleshooting anything, the first place you're going to want to go is the log files. Far too often I see people starting the process of troubleshooting in Linux, and I'll ask them, what did the logs say? And I get a blank stare. I don't know. I didn't look at the logs. If you're not looking at the logs, you're not troubleshooting. Almost every package, application, service, they all put things into log files that you can look at. It's the only way we can piece together what happened when something goes wrong, is to use these log files. There are a lot of log files in Linux, and there are different ways to manage them. I'm going to divide this lecture really in two parts. There's the legacy way of managing logs and the new way of managing logs, and I'll talk about both. So our syslog is a legacy logging utility. One of the really cool things about our syslog is that it allows you to do logging to external systems, right? So let's say you have an Apache web server and you want the logs for Apache to not be on the local system, but instead log to some other system. You can do that. You could tell it, hey, don't put your log entries in the local system. Instead, when you call our syslog, have it write to a remote logging server. Why would you do that? Because you want to aggregate logs from many servers. Think about if you had 20 or 30 Apache web servers all clustered together, all load balanced behind a load balancing switch, for example. We don't talk about load balancing in this class too much. It's kind of a networking topic, but the idea is that, traffic coming into your data center might be distributed across many Apache web servers that are all doing the same thing. They all have the same job, and you distribute that across lots of different servers. And that's for basically balancing the load for really high volume web services, for example. And Apache isn't the only thing you would do this with. There are lots of different network-based services that might be high volume that you would want to load balance. But if you're doing that, if you want to track traffic somehow with logging, if you have to go into 30 different systems to read the logs to figure out what's going on, when you're troubleshooting something, it's impossible, right? So being able to aggregate everything into a centralized logging mechanism is kind of cool, right? So our syslog is the mechanism that does that, and your book certainly talks a little bit about that and some of the different services that support that. So just this slide deck has a couple of examples, and these are all from the textbook that show you how you might use our syslog to take a look at logs. And I'm not going to talk too much in detail about our syslog because there's a newer, more modern mechanism that's going to be more common. And I'll show you that here in just a few slides. But again, just so you have, in the PDF of this slide deck, you can take a closer look at these. It's also in the textbook. All right, so our syslog and klog handle system kernel events. There's another logging mechanism. Again, this is also legacy, which is audit D. So audit D is for logging events of general user activity. So it's less about logging errors and warnings and things like that. It's more about logging what does a user do. Audit logs are more benign in the sense that it's telling you that somebody accessed a file or accessed some utility, or they did something with some software. And software, by the way, determines what types of things it outputs in these audit logs. So it'll output things into these audit logs, and then you can use various commands to search those audit logs. You can either look at different types of activities, or you can search the audit logs. So you can see who accessed certain files. Databases do this a lot, right? Do audit logging. But Linux does have a mechanism baked in to handle audit logging. And these are just some of the options with the various audit logging tools that are built into Linux, the audit report and audit search commands. So this is just a example of somebody searching the audit logs or viewing the audit logs rather, and running a summary report in a Linux system. And again, these are all from your textbook, also in the PDF of this slide deck. So the next topic we're going to talk about after audit logging, again, I'm scrolling through these because I'm not going to talk about them in detail, but these are, if you're looking at this slide here, this is a list of different log files. And if you wanted to go and analyze logs, usually you have to go into var log, and then you would, you could use something simple like the cat command to cat out the contents of a log. You could use the grep command to look for, to use regular expressions to find things in log files, which we learned about in this course already. However, and again, here's another list. This is all from your textbook. But more commonly, if you're looking in these log files, more commonly, we're not going to go look in the log files directly. We're going to use some logging mechanism, such as what's available in System D. So System D, starting with System D, there is, instead of logging be sort of, distributed, right, and managed by individual applications and, having to go into different log files to find things, instead it's all consolidated in the journal D command. Journal is basically the logging mechanism in System D. So if a service is running under the management of System D, all of the logging messages that it can generate are handled by Journal D, logged out by Journal D, and you can view them with Journal D, but also manage the logging with Journal D. Journal D automatically handles all of the rotation of logs, the FIFO or LIFO of log files, right? So how much data is retained in the logs, all of that stuff is automatically just handled by Journal D. So it's a built-in logging facility in Linux, very similar to what our syslog might do, but it's at the service level. So it's managed within System D itself. So it's definitely a more modern mechanism. You can think of it as somewhat like the event viewer in Windows, right? So Windows has the event viewer. It's managed by the operating system. If you write an application, you can have it log out events to the event viewer, and then you don't have to worry about log file rotation and managing log files and things like that. The operating system does it all for you. And because you're locked into certain formats, it makes it more searchable across many different processes and so forth. So I did just want to familiarize you with Journal D, some of the options that it has. You can, again, this is all in your textbook. You can take a look at this in more detail. In the lab, I'm going to ask you to use Journal D to take a look at log files for a process and do some basic troubleshooting of a process. So Journal D with no arguments is going to list all entries from oldest to newest, regardless of the process, right? So it's consolidated. It's all the processes in one giant log. And what's kind of cool about that is you can run Journal D and you can tail it so that you're seeing everything in real time, right? All these log entries in real time. You can kind of see what's happening in real time on your server, although it'll scroll by pretty quick if you've got a busy web server, for example. But you can pass some arguments to it to hone in on just certain daemons or processes or services, right? So just unit files, right? So we talk about units in System D. We can show just those units log entries when we run the Journal D command. And there's other ways you can also identify processes using Journal D to hone in on those log messages. You can also do some filtering with Journal D. So for example, you can show log entries that are only associated with certain users or certain user space. And again, certain unit files and so forth. You can tell it to only show a certain number of log entries so you're not getting overwhelmed. You can even tail it so that you can see it in real time, which is kind of cool. And you can pass in regular expressions to do more complicated searches. So with straight log files, you might pass them in the grep by piping them in the grep to output certain patterns. But with Journal D, you can just pass the regex right in the command when you run Journal D, and it'll do its filtering on its own for you. So it's all baked into Journal D. So these are just some of the fields that can also be specified with some options. And again, I'm going to have you play with this in the lab environment for your last lab for this course. The last 10 slides in this presentation are just some examples of troubleshooting scenarios. It describes a problem, and then the next slide kind of talks about what the solutions might be or how you might go and address that problem. So these are from your textbook. It's in the PDF of the slide deck. I'm not going to go through these, but I want you to just show you real quick that they're here and you can review those to get some kind of sense of what troubleshooting looks like with Linux.